Okay, so we've learned how to find the inverse of a 2 by 2 matrix, but we're now going to figure out how to find the inverse of a 3 by 3 matrix. And in order to do that, we need to know something about the matrix transpose. Okay, so this is just to build up to help us find out the inverse of a 3 by 3. So A with a little t in the corner is called the transpose of a matrix A. All this means is that the rows and columns become interchanged, they kind of switch around. So for example, the transpose of a 1, 2, 3, 4, 5, 6, a 2 by 3 matrix becomes a 3 by 2 matrix, and you'll see that that first row became the first column, the second row became the second column, or you could think that the first column became the first row, etc. You'll also notice that M times N matrices becomes N times N matrices. So this first one here is a 2 by 3, it's 2 rows and 3 columns, and this one becomes a 3 by 2. So just do a very quick couple of examples here. I like going from rows to columns. So that first row, which is 7, 1, 2, is going to become the first column, and then the next one, which is 6, 1, 5, is just going to go down as 6, 1, 5 like this. The transpose of a 3 by 3 matrix just does the same things. I like doing rows to columns, so I'm just going to read them as I go. So the first row is 1, 2, 0, the second row is 4, 5, minus 6, and the third row is minus 1, 8, 2. So I'm kind of like reading it and at the same time just writing it in a different direction. So that is the transpose of the matrix A. So you need to know that in order to find out the inverse of a 3 by 3 matrix. Now, finding a 3 by 3 matrix is actually the same process as finding a 2 by 2 matrix, but it's actually just like a specific case that we've got here. So to find the inverse of a 3 by 3 matrix, we follow this long process that we've got here, but I'm going to show you how it's the same process as with a 2 by 2. So let's try it with a 2 by 2, and then we're going to then extend these ideas to a 3 by 3. So the method that we previously used was a specific case of a more general method, which can be used for matrices of any size. So although I'm saying we're doing it for a 3 by 3, in theory you could do this for 4 by 4 and other ones as well. So the first thing that you do is you find the determinant, and we're going to do it for a 2 by 2. So the determinant of this matrix that we've got here is just going to be 4 minus 6, and 4 minus 6 is minus 2. The next thing that you do is you form a matrix of minors. Now remember, a matrix of minors is when you cross out, to show you what I mean, it's when, if you wanted to find the matrix of the minor of 1, you would cross through and you would find out the determinant of that last part that you've got there. So the determinant, when you do it of 1, this matrix of minors, is just going to be 4, because the determinant of the element that you have left is just 4. So when I then do the next part, I do the determinant, the minor for 2. The minor of 2 will be the leftover part, which is 3. The minor of 3 will be the leftover 2. And the minor that you have of 4 will be the leftover, which is 1. So that's what you've got there. You've got your matrix of minors. Remember we learned about minors earlier on. The third step is to form a matrix of cofactors. Now, a matrix of cofactors is basically where you take the elements and you make them follow this pattern, where it starts with a plus and then it alternates. So there'd be plus minus, and then it would be minus plus. So you're going to take this matrix that you've got here, and we're going to apply that pattern so that this one and this one stay the same, and the other two negate. So you're going to have minus 2 and minus 3. And then your last step to find the inverse is to do 1 divided by the determinant multiplied by 4, 1, minus 2, multiplied by the transpose of that matrix. So it's going to be 4 minus 3, and then minus 2, 1. So there's quite a lot of steps. You find the determinant as normal. You do this new part where you find a matrix of minors. You then change it so that any of them that lay in the negative parts have to negate, like this. And then the last stage is to do 1 divided by the determinant multiplied by the transpose of that previous one. Now let's just check if this would have given us the same in our kind of normal way of doing this. Well, it would just be 1 divided by the determinant. We would swap the 4 and the 1. We would negate the 2, and we would negate the 3. So yeah, actually it does give us the same thing down here. It's just kind of like a shortcut method for this. So let's try the inverse now with a proper 3 by 3 matrix. So let's have a look. First of all, we find the determinant of this matrix because we know we're going to need that. I'm probably going to go down here because I'm going to have a 0, which is going to make it nice and easy. So I'm going to do 1 multiplied by crossing through here and here, the determinant of this bit. So that's just going to be a 0 minus 1. My next part is going to be a 0, which I have from this bit. And so my final part is just going to be using this. I'm going to cross through that. My determinant of that last bit is going to be 2 multiplied by 3 minus 4. So that's 1 times 1 plus 0 plus 2 times 3 minus 4. Well, 3 minus 4 is minus 1, so it becomes minus 2. And so it becomes a very nice answer of just minus 1. Now I'm going to do the matrix of minors. So here is my matrix of minors. I'm just going to do it to the original one. Well, this one's pretty easy actually, because we've already calculated it from up here. We already calculated it as just 1. Yep, we had, 0 minus 1. So that's just going to become a 1. Now, the next part we know is we've already done as well. Oh no, we haven't done that bit. Sorry, we're going to keep going. We're going to go across the top instead. So the minor for this 3 that we have would be 0 minus 2. The next one that we would have would be, I'm going to do it for the 1, it would be 0 minus 8. Then I'm going to do the 0, 1, so that's going to be 3 times 0, which is 0, minus 1. So 0 minus 1 is 1. Now I'm going to do the minor of the 4, so you get the 1 times 0, which is 0, and the 2 minus the 2 times 1, which is minus 2. Now I shall do this element over here. So that's 1 times minus 1, that's minus 1. And I'm going to minus 6. Minus 1 minus 6 is minus 7. This one here, 3 times 1 minus 4 times 1. That's just 3 minus 4, which is minus 1. And then I'm going to do for this one, 1 minus 0. And then my last one, I have got 4 minus 0, so it's just 4. Now I'm going to do the matrix of cofactors. This is the pattern for the cofactors. You always start with plus, and it's going to be like pluses down this leading diagonal, and then it just alternates everywhere. Now this doesn't mean that you need to make them positives and negatives. What it means is the ones that are in the negative bits, they actually just need negating. So it doesn't mean they have to be negatives. It means they need negating. So this, and this will all need negating. The rest of them stay the same. So this will stay the same, 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 this will stay the same. This will negate, this will negate, this will negate, and this will negate. Okay, so all that's left to do is actually just to write down what the inverse is. So it's going to be 1 divided by the determinant multiplied by the transpose. Don't forget the transpose of this matrix. So that is going to be, the first row becomes the first column, 1, 2, minus 8. Then we have minus 1, minus 2, 7, minus 1, 4. And then I'm actually going to multiply by this 1 over the determinant, which is just minus 1. So it means everything inside is just going to negate 1 final time. So you get minus 1, 1, 1, minus 2, 2, 1, 8, minus 7, minus 4. Now don't be afraid, you might get loads of fractional terms in here because of this 1 over thing. Mostly this stage here is all going to be integers that are positive and negative, but then you are going to get some fractional terms because of this 1 over the determinant bit. Now you should always check to see if you've got this right. So I've actually already put this into my calculator, and I'm just going to see if it gives us the same answer. Oh, not to the power of minus 10, but just to the power of minus 1. So let's just see if that's right. We have minus 1, 1, 1, minus 2, 2, 1, and 8, minus 7, minus 4. So let's see if that's right. Yep, minus 1, 1, 1, minus 2, 2, 1, 8, minus 7, minus 4. So you can obviously do that on your calculator. And if it is ever all numbers, you should just do it on your calculator. Obviously, you're going to practice doing it without, because of course, we will have some that are non-numerical as well, some algebraic ones. So what have we got here? Okay, so this time they've told us what A is equal to, and they've said that there is a matrix B such that AB inverse is equal to this thing. And first of all, they want us to show that A inverse is equal to A. Now, doing the inverse of a matrix, yes, you could do it on a calculator, but let's imagine that they wanted you to do the whole process. It's really, really long, and we want to try and avoid this long process, and we want to see if there's a smarter way of doing this. So first of all, do you remember we mentioned this earlier on? If A inverse is equal to A, then A is self-inverse. If A is self-inverse, then we know that A inverse multiplied by A must be equal to I. In other words, if A times A, because these two things here are the same as each other, so if AA equals A is equal to I, or in other words, A squared is equal to I, then A inverse must be equal to A. So all I actually need to do to show that A inverse is equal to A is all I need to do is just calculate what A multiplied by A is, or in other words, just what A squared is. Calculate A squared. So I'm just going to do minus 2, 3, minus 3, 0, 1, 0, 1, minus 1, 2. I'm just going to multiply it by the minus 2, 3, minus 3, 0, 1, 0, 1, minus 1, 2. And I know it's going to be equal to that. I know it's going to be equal to the identity matrix. If you wanted to, you could spend your whole time doing it and wasting time in the exam. But we know that these two things multiplied must be equal to the inverse because they've said that these things are the same as each other. So we can calculate it and we can say as A inverse equals I, A must be equal to A inverse. That's it. So didn't even have to find out the determinant, the transpose, the cofactors, the minors, all of that sort of stuff. And then part B, I also want to think, is there a smart way of being able to do part B of the question? So part B of the question is also going to rely on one of these things that we said earlier. Earlier on, we proved that PQ inverse was equal to, the other way around to how you'd expect it, Q inverse, P inverse. So let's see if we can think about how we would do it with this thing that we've got here. Now we know that AB inverse is just going to be the same as B inverse A inverse. So we know that B inverse A inverse is equal to this 3 by 3 matrix that we've got here. And I want to find out what B inverse is equal to. Well, if I want to get rid of this A inverse here, I could multiply it by A, and I could multiply this side by A as well. So my shortcut to find out what B inverse is going to be, remembering like this A inverse and this A cancels, it's just going to be by calculating these two matrices multiplied together. So this is a really tricky question because the theme of this exercise is inverses, but actually we haven't even done it with an inverse. So I'm going to multiply it by A, which is 2, 3 minus 3. 0, 1, 0, 1, minus 1, 2. And then you can actually just put that on your calculator to find out what it's going to be equal to. So I'm just going to do this super quick on my calculator. I'm going to add in two matrices, which are 3 by 3s. And they're going to multiply together. And I'm just literally going to type in all the numbers. So what is it? It's 8 minus 17, 9, minus 5, 10. Minus 6, you can do this on your calculators at the same time, minus 3, 5, and minus 4, that's the first one. And then I've got minus 2, so easy to make mistakes here because you've just got so much typing in, 3 minus 3, 0, 1, 0, 1, minus 1, and 2. I'm not even going to show you that, but you come up with minus 7, minus 2, minus 6, 4, 1, 3, 2, 0, 1. So you've done this whole question without finding any inverses, and we actually used some of the proofs earlier on. So try and be smart here. Use this fact that we learned about here, and also use this fact that if A is equal to this, then A squared is equal to this. But of course, you may need to be able to do the determinants without either of these methods, with like a calculator method or with this kind of shortcut method, and you will need to know how to do it with algebra. So we're going to see if we can do this one with algebra, and we're going to see if we can do it without having to look back at the different steps that we've got. So they've kind of broken it down a little bit. The first thing they wanted to do is to show the determinant of this one. So for the determinant, I'm probably just going to do the traditional going across the top row, but if you wanted to, you could use this. So I'm going to say that the determinant of this matrix is going to be k multiplied by 0 minus 2, or minus 2. Then instead of it a minus 1, it's going to be a plus 1, because remember you always switch it up for this middle one that you've got here. So it's going to be plus 1 multiplied by, well, 1 times 1 We're now doing it for these leftovers. So that's 1 minus minus 3. And then for the last part, you've got a plus 1 multiplied by the minus 2 minus 0. So you get here minus 2k plus 4 minus 2, which is just 2 minus 2k as they wanted. And now they want us to find the inverse matrix, and it's pretty hefty, it's 5 marks. So we want to make sure that we can definitely do this one. So we're going to start off by forming the matrix of minors. So this time they've called it here M. So let's say the matrix of minors, let's this time call it A so that we're using a different letter. Well, this might need to be kind of big. So we're going to have the K's minor is going to be 0, 2, minus minus 2. So it's actually going to be, sorry, not minus minus 2, just minus 2. So it's just going to be a minus 2. The 1's minor is going to be the 1 minus minus 3, which is this bit here, a 4. And the other 1's minor, the 1's minor that we have here, is going to be the minus 2, which we actually calculated earlier on. So if you want to, you can find these minors as a shortcut from the first row that you've done. But we've got to keep going. So we're now going to have minus 1 minus minus 2. So that's minus 1 plus 2, which is 1. So easy to make a mistake. I hope I haven't made one so far. Then this next part is going to be k minus 3. Can't do this on the calculator, so it's very long. And then we've got minus 2k minus minus 3. Okay. Then we've got here 1. For the next one, we've got minus k minus 1. Minus k minus 1, yeah, that's correct. And then for the last one, we've got 0 minus minus 1. Okay, so we've done the matrix of minors. Now we're going to do the matrix of cofactors, which means we're going to put some negation. And remember, the ones that you negate are this one, this one, this one, and this one. The rest all stay the same. So that's going to stay the same. That's going to negate. That's going to stay the same. That's going to negate. That's going to stay the same. That's going to negate. So it's going to become 2k minus 3. That's going to stay the same. That's going to negate, and that's going to stay the same. Now we're going to go straight into the last step. So it's going to be in terms of k. So it's going to be 1 over the determinant, and we're going to transpose this matrix that we've got here. So we're going to do a C. It's going to be 1 over the determinant multiplied by the transpose. People always forget the transpose, so don't forget it. So it's going to go minus 2, minus 4, minus 2, minus 1, k minus 3, 2k minus 3, and then 1, k plus 1, 1. And that, as horrible as it looks, is the inverse of that matrix. I really hope I haven't made a mistake there. If I have made a mistake, let me know. But it's so easy to slip up on these, so you've got to try and take it really, really slow. So this is everything that you should need for exercise 6E.